This video is about speed. Speed is defined as the rate of change of distance with time. Speed is measured by looking at how fast you're moving. It is how far you travel in a certain amount of time. So if you look at the example, we've got the person walking starting on the start line, and after each second I'm going to show you where that person's got to. Each line on the graph, on the diagram on the bottom, is 1 meter. So when time equals 0, they're at the beginning, so the distance travelled is 0. Okay, so 1 second later, the person is now at the 1 meter mark, which means they've travelled 1 meter in 1 second. So that's a speed of 1 meter per second. So in a second, they travel another meter. So that means 1 meter in the second, or 2 meters in 2 seconds. At 3 meters, so that's 1 more meter in 1 more second, or they've travelled 3 meters in 3 seconds altogether. By the time they get to the finish line, they've done 4 meters in 4 seconds. This means that for each second, the walker moved 1 meter. This is a speed of 1 meter per second. Meter per second is the unit for speed. Okay, so let's have an example of what happens when somebody's moving faster. This time the person's running. Again, they're starting at the 1 meter mark and seeing how far they get. So after the first second, they're now at 2 meters. So they've run 2 meters in 1 second. That's a speed of 2 meters per second. Now they have run the extra 2 meters in another 2 seconds. So they have now run 4 meters in total, in a total of 2 seconds, which gives them a speed of 2 meters per second. So the speed that we're looking at and how we can calculate it is linked to the distance and the time. So the speed is the distance moved per time. So the speed can be calculated by dividing the distance travelled by the time it took. So we write that as the equation: speed equals distance divided by time. So let's have a go at working out an example. So here's an example question. A person walks 6 meters in 3 seconds. What is the speed of the person? So the first thing I do is I write down what the question is telling me. I know the distance is 6 meters, I know the time is 3 seconds, and it's asking me to work out the speed. So the first thing I do then is I write down the equation. Speed equals distance divided by time. I then put numbers into the equation. So the speed is going to be equal to the 6 meters divided by the 3 seconds, which is going to give me an answer of 2. And then I put the unit meters per second. We can do this calculation by using a triangle. Okay, so in a triangle, you cover up the thing you are trying to find from the question, and the rest of the triangle tells you the answer. So if we start off by covering up speed, that tells me that the equation for the speed is going to be the distance divided by the time. So speed equals distance divided by time. In this question, we're going to try and work out what the distance is. So if I've got a question where I'm given the speed and the time, I want to work out distance. I cover up the distance and I do speed times time. So the equation for distance is speed times time. The final equation we can do is for time. So this time I cover up the time and I get the equation distance divided by speed. So the equation for time is distance divided by speed. So now we have those 3 equations. We can try equations where we have to rearrange the triangle to get the things we want. So let's start off with the question on the left. A car travels for 2 minutes at 25 meters per second. How far will the car travel? So the first thing I do is the same as before. I write down what I know. But this time you note that when you write down the time, in the question it's 2 minutes. but I need that time in seconds. So what I have to do is convert 2 minutes to seconds. The way you do that is you times it by 60, as there are 60 seconds per minute. So that gives me 120 seconds. The speed is 25 meters per second. So now I work out the distance. So the first thing I do is I write down the equation using my triangle from the previous slides. I then put the numbers in that I've written down for the question, making sure I'm using the correct units. And now then times the two numbers together in this case, and I get the answer 3000, and I make sure I include the unit m. We always measure the distance in meters. Okay, so the question on the right. This time we're looking at a train travelling at 50 meters per second, and it travels for 1000 meters. What the question wants us to do is find out how many seconds it takes to do that journey. So the first thing I do again is I write down all the information I know. I know that the speed equals 50 meters per second, and I know that the distance is 1000 meters. It's asking me to work out the time, so that is the thing I don't know. I look at my triangle, and I write down the equation from my triangle. It says time equals, and as we saw before, time equals distance divided by speed. I put the numbers in from my question, so I've got the 1000 for the distance and the 50 for the speed. 1000 divided by 50 is 20, so my final answer is 20 meters per second. This table shows you some examples of the kind of speeds you can expect to try and remember for different objects. A walking person has a top speed of approximately 1.4 meters per second. A bicycle riding on a road would have a safe top speed of about 8 meters per second. The fastest human alive, which are currently making this video, is Linford Christie. His top speed was measured at 12 meters per second. A car following the maximum speed limit in Britain would be travelling at 30 meters per second. This is 70 miles per hour. A Formula 1 car would be measured at a top speed of 100 meters per second. A passenger plane, like a 737, would have a top speed of 250 meters per second. A bullet would have a top speed of approximately 1000 meters per second. Space Falcon X Heavy would have a top speed of 11,000 meters per second. This would mean it travelled at 11 kilometers every second. To get from Birmingham to city centre to the school, it would take about half a second. These numbers are ones that you might be asked to remember in exams, or ones that you could use for example calculations if you needed to show somebody how to calculate speed.